Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 18 to 23, which account for 18 of these marks. AQA Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18. In a game, an ordinary fair six-sided dice is rolled. The fair spinner shown is spun. So we have a spinner, it's got 3 sections. This one is worth 2x, 3x, and then x squared. The score is the dice number substituted into the spinner expression. So we're going to roll a dice. Whatever number we get, we substitute it into the expression that the spinner lands on. So if we rolled a 1 and it had landed on 3x, we would do 3 times 1. It wants us to complete the table to show all of the possible scores. So this is part A. So what we're doing is we're substituting these values into these expressions. So remember, we've got a calculator to make life a little bit easier. So 2x, 2 times 1, 2 times 2, 2 times 3, 2 times 4 is already done, 2 times 5, 2 times 6, and then 3 times 1, 3 times 2 is already done, 3 times 3, 3 times 4, 3 times 5, 3 times 6, and then x squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is already done, and 6 squared. So we've completed the table for 2 marks. 18b. A player wins the game if their score is 10 or more. Work out the probability that they win the game. So we need to look back at this table to start off with. We're looking for scores of 10 or more. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 scores that are 10 or more. So that's going to be the top of our fraction. So 8 that are 10 or more. And then we need how many scores there are in total possibly. So we've got 3, 6, 9, 12, 15, 18. So the probability is 8 out of 18. Now it doesn't ask us to simplify it, so I'm going to write that directly on the answer line there. 18c. The game is played 711 times. Estimate the number of games that are won. So to estimate the number of games that are won, we're going to do the number of times it is played multiplied by the probability of winning. And it's a calculator paper, so I'm just going to pop that all into my calculator. So 711 multiplied by 8 over 18 is 316. So we estimate that 316 games were won. (19a). Part of a regular polygon is shown. Assume that the polygon is an octagon. So I know an octagon is 8 sides. Work out the size of angle x. So angle x is an exterior angle of this octagon. And exterior angles sum to 360 degrees. So if I'm trying to find one of them and it's a regular polygon, I know that all of the exterior angles are going to be the same size. So I'm going to do 360 divided by the number of sides. It's a calculator paper. 360 divided by 8 is 45. So each of those exterior angles is 45 degrees. 19b. In fact, the polygon has more sides than an octagon. What does this mean about the size of the angle x? Well, that means that the number we're going to be divided by is going to be bigger. So 360 divided by a bigger number. So this answer is just going to get smaller. So the answer will be less than the answer to part A. Question 20. Write down the translation vector that maps shape A onto shape B. So we're going from shape A to shape B. So I'm going to find a vertex, a corner of the shape, find the corresponding corner on the new shape that we're mapping it to, and now I'm just going to plot the journey. So I want to see how far along it's gone. So I'm aiming to get to here, directly opposite. So 1, 2, 3, 4. Checking that scale there, it's definitely going in 1. So it's gone 4 to the right, and then 1, 2, 3 down. So in terms of our translation vector, it's the long brackets, the tall brackets. The movement left or right goes on the top. We've gone right, so it's a positive movement of 4, but we've gone down 3, so it's a negative 3 underneath. Question 21. So first of all, we're given the formula for the volume of a sphere. So it's 4/3 multiplied by pi multiplied by r cubed, r being the radius of the circle or the hemisphere sphere. So a bowl is a hemisphere, which is half of a sphere with a radius of 12. So we've been given that value r there, look. Water is poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show your working out. So first thing we need to do is find the volume of this bowl. Okay, so they've given us the formula for the volume of a sphere, but we've got half of a sphere here, so we're going to have to find that volume and then half it. So we're going to start by substituting. So volume equals 4/3 multiplied by pi multiplied. So the radius cubed, the radius is 12, so we're going to put 12 cubed. And then we're going to pop that in our calculator. So we've got 4/3 multiplied by pi multiplied by 12 to the power of 3, and then we're going to press equals. So this is our volume, 7,238.2294. I'm writing the whole value down. I don't want to round at this point, just in case rounding causes any little errors later on. This is the volume of a full sphere. We've got half of a sphere, so let's divide that by 2. So when we divide this by 2, we get 3,619.114737. So that's the volume of the hemisphere, of the bowl. Okay, and that's in centimetres cubed, which is important to note here. So it says water's poured into the bowl at a rate of 325 centimetres cubed per second for 8 seconds. So let's see how much would get filled in 8 seconds. So 8 times 325 tells us that after 8 seconds we'd have 2,600 centimetres cubed filled in that bowl. It wants to know if more than 70% of the bowl is filled. So we need to figure out if this value is more than 70% of the total volume of the bowl. So let's work it out. We've got 2,600 over our volume, and then we're going to multiply it by 100. So 2,600 over 3,619.114737 multiplied by 100 gives us 71.8407792. That's our percent, because we're dealing with the amount that we have out of the total amount multiplied by 100. So 71% is more than 70%, so you can just say yes at the end there. Question 22. Show that these two rectangles are similar. So for these two rectangles to be similar, they will have a scale factor that's the same. That gives them a proportional relationship. So we're going to find the scale factor for these shapes and see if it is the same. So If I was using these two corresponding sides, the larger divided by the small, so 8 divided by 5 gives us a scale factor of 1.6 for the width of the rectangle. So let's check if it's the same for the length, because if we get the same scale factor, they're similar. If we don't, then they're not similar, because that scale factor would multiply all of the lengths to make the new similar shape. So now we're going to do 19.2 divided by 12. Again, that is 1.6. Same scale factor, so similar. Question 23. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 4x over 3 tea bags per minute. Okay, so they've told us that in 1 hour we can pack X boxes. So 1 hour means we have 80 times X tea bags, because each of those X boxes contains 80 tea bags, and that's in 60 minutes, because there's 60 minutes in an hour, and we're aiming to work in minutes here, aren't we? So after 60 minutes there are 80x tea bags. So after 1 minute, which is what we're aiming for, the per minute, if we divide by 60, we have 80x over 60 tea bags. So we're going to simplify this expression here now. So I can divide the top and the bottom by 10, so I get 8x over 6, and then 8 and 6 can both be divided by 2, which gets me to 4x over 3. So I've shown that 4x divided by 3 tea bags per minute are packed by that factory.